So may I proceed to the next is the chemical properties. So far as chemical properties is concerned, I take separately chemical properties of RX, I mean alkyl halide. It gives three types of the reaction. First is the nucleophilic substitution reaction. Second is the alpha beta elimination reaction, and third is the reaction due to metal. So dear students, categorically there are three types of the chemical reactions exhibited by haloalkanes or so-called alkyl halides. First is the reaction is due to nucleophilic substitution reaction. We take first nucleophilic substitution reaction. So what are nucleophiles? Anybody can tell me? Electron rich centers are the nucleophiles. That is electron efficient molecule. You know it better. What is that? Lewis base, ammonia, alkoxy, alcohol, RSH, thioalcohol, primary amine, secondary amine and tertiary amine all contains lone pair of electrons. They are called nucleophiles. But some nucleophiles are known as ambident nucleophile. What do you mean the term ambident? Such nucleophile contains two donor atoms, but at the time only one can contribute to the lone pair of electrons. So ambident nucleophile means such nucleophiles which contains two donor atom but only one can donate. So cyanide, isocyanide, nitrite, nitro, thiocyanate, isothiocyanate are the typical examples of ambident nucleophiles. So cyanide and isocyanide. Nitrite, it is nitrite and it is, what is that? Nitro. It is thiocyanato, isothiocyanato. Like this, these are the ambident nucleophile. So come to the first definition. First reaction is the nucleophilic substitution reaction. First is the nucleophilic substitution reaction is the alkyl halide या haloalkane react with KCN to form alkyl cyanide as a major product, but alkyl isocyanide as a what product? Minor, and this is what is that? Major. Why? Similarly here, alkyl halide when react with silver cyanide to form isocyanide as a what product? Major product, and cyanide as a what product? Minor product. Question is why it happens like this? This is a very important question. Go through the question properly. Alkyl halides, I mean methyl chloride, ethyl chloride, whenever they made to react with potassium cyanide or sodium cyanide to form cyanide as a major product. But isocyanide is the side product or the minor product, not the chief product. Just like once you change the reagent, you take silver cyanide, then the situation is changed. Now in this case, Alkyl isocyanide is taken as the major and this is as the minor. Why it happens like that? Anyone can explain it? Because of potassium cyanide is predominantly ionic compound. KCN is mainly or predominantly what compound? Ionic compound. So it gives potassium ion and cyanide ion. Cyanide, once you see the anatomy of the cyanide, octet is done and then one electron due to the negative charge like this. So in this case, both carbon and nitrogen are in a position to donate the lone pair of electrons. It point is to be noted. Carbon and nitrogen are in a position to donate lone pair of electron, but the bond between carbon and carbon is more stable than carbon and what? Nitrogen. As such, alkyl cyanide is formed as a what product? Major products. It is formed as a major products. But on the other hand, once you take the silver cyanide, it is mainly covalent. See the other side? But silver cyanide is mainly covalent and only nitrogen is capable or in a position to donate lone pair of electron. Thus, isocyanide is formed as a major products. See the structure of AgCN, sharing of one electron, octet is done only, so this electron can be donated from nitrogen to other element. So always keep in mind, in case of the silver cyanide, isocyanide is formed as a major product and that is formed as a minor product. So is it clear? I have made it clear to everyone. So it is one of the important nucleophilic substitution reaction of, you can say, haloalkane. Now next is the mixture of amines formation. You know ammonia is also a Lewis base and very good nucleophile. So you take Rx plus ammonia at 100 degrees Celsius in a sealed tube apparatus, 1X and 1H. HX is lost, RNS2 is formed. What degree amine? It is primary amine. 1 degree amine. There are 2 hydrogen atoms. Further it undergoes reaction with another molecule of the alkyl halide. Same condition, 100 degrees Celsius in a sealed tube apparatus. Now, how many R? This R and this R. That means R2NH. What degree amine? 2 degree. Further, it reacts with third molecules of the alkyl halide R, and tell me what degree amine? 3 degree. Now addition reaction takes place and this R, 3R and 1R, that forms R4 N positive and X negative. It is known as quaternary ammonium salt or tetraalkyl. How many alkyl groups? 4 alkyl groups. So it is called as tetraalkyl ammonium halides or it is called as quaternary ammonium salt. These mixtures are separated by which method? Anyone? Fractional distillation. Mixtures of amines can be separated by taking the method which is called as fractional distillation. This is also known as Hofmann's ammonolysis. Hofmann's ammonolysis method. So alkyl halide, ammonia, primary amine. Take again second molecule of alkyl halide, secondary, tertiary, as well as it is known as quaternary ammonium salt. Now the third is the formation of ether. See, RX, alkyl halide, sodium alkoxide in presence of dry ether. NaX is lost, ROR. Once you take the same kind of the alkyl groups, what kind of the ether? Symmetrical ether. I have told you in previous class. Now RX, NaOR dash. Now NaX. I have changed the alkyl groups. Keep in mind. Okay. Then minus NaX, ROR dash. Is it symmetrical or unsymmetrical ether? So it is very much unsymmetrical ether. For example, if I say ethyl chloride plus sodium methoxide, Na and Cl. NaCl is lost here. So this is the C2H5OCH3, ethyl methyl ether. Or in IUPAC system of nomenclature, oxygen used to select the shortest route. So oxygen used to move to that side having lesser number of carbon. Obviously, oxygen used to move this side. As such, it is methoxy and this is the ethane. Is it clear? I made it clear, everyone. So in IUPAC system, it is taken as methoxymethane, but in common system, take it alphabetically: ethyl methyl ether, ethyl methyl ether. It is not symmetrical; it is unsymmetrical ether. Now, next is the formation of nitrite. Another method is the alkyl halide is taken as, this is the NaO and double bond O, sodium nitrite. So Na and X is out, NaX, RO and double bond O, alkyl, what is that? Nitrite. But again you apply the same case as you have discussed earlier, AgO and double bond O. This is the AgX is out because silver is mainly covalent. R and double bond and coordinate bond O. So this is the nitroalkane. Better to say AgNO2. You have to write like this. Nitroalkane. Formation of alkyne. How to get the alkyne? As such, you can see RX, sodium ethionide, NaX, RC triple bond H. It is the alkyne. If I give you a conversion, ethanol to but-1-ine. How do you get, anyone? If my question is ethanol to but-1-ine, anybody can suggest any method how to get the conversion? First you change alcohol into halide. Then you take the mean salt while I have taken this reagent. First of all you take PCl5 minus POCl3 minus HCl, CS3, CS2Cl, and then further you take sodium acetylite NaCl is out, NaCl that forms CS3, CS2, C triple bond H. This is actually but1 ine. So how do you get ethanol to but1 ine? By taking, you can say, sodium acetylites. Now another question is very important. Alkyl halide, when reacts with aqueous NaOH or KOH to form alcohol as a major products, but with alcoholic NaOH or KOH or ETONA in presence of alcohol. Sodium ethoxide with alcohol to form what is that? Alkene as a major, or you can say what is that? Chief products. Why? Anyone can explain it? My question is very simple. Alkyl halide, whenever made to react with Rx plus NaOH or KOH in water, I mean aqueous. So minus NaX, ROH is the major product. But whenever alkyl halide is treated with NaOH or KOH in presence of what is this? Alcohol, then NaX is out and alkene is formed. For example, CS3, CS2Cl. It is the alpha and it is the beta. I take NaOH in presence of alcohol, Na and Cl, minus NaCl is lost, OH and H is lost. CS2, double bond CS2, what is this? Ethene is formed. Why it happens like this? Anybody can explain? The haloalkane, whenever made to react with aqueous NaOH or KOH to form alcohol as a major product, but in presence of alcoholic NaOH or KOH to form alkene as a major or chief product. Reason behind is very simple. Water acts as a stronger polar solvent that gives the complete cleavage. But alcohol is a poor polar solvent, it cannot give the complete cleavage. So, in that case, water is lost here. So, simple answer is, you can write the answer, कि water acts as a stronger polar solvent which prefers nucleophilic substitution reaction, while alcohol is a poor polar solvent which prefers alpha beta elimination reaction. As a matter of fact, as such, there is always race or competition between substitution and what reaction? Elimination reaction. That is why with aqueous KOH or NaOH alcohol is formed as a major product, but in presence of alcohol, it forms alkene as a major product. It's all about the nucleophilic substitution reaction. In my next class, I'll discuss types of nucleophilic substitution reaction, that's SN1 and SN2, with certain differences, and taking stereochemistry by chirality and racemization. It's all right. I hope I have made it clear. Preparation completed, physical properties completed, nucleophilic substitution reaction, although it is in progress. And the next class we take, after completion of the SN1, SN2, alpha beta elimination by taking Sajev rule, as well as to discriminate which one is the minor and which one is the major product, and then reaction with metals. Thank you very much. Have a nice day. God bless you.